In this video, we're going to take a look at what it means for an angle to be in standard position, and also look at some terms and definitions relating to angles in standard position. So the first thing we're going to review is exactly where are those four quadrants. So quadrant number 1 is in the upper right-hand corner, quadrant number 2 is in the upper left-hand corner, quadrant 3 is down here, and quadrant 4 is in the lower right-hand corner. And you can see that if you were to trace out the path from quadrant 1 to quadrant 4, you would trace out the letter C, which is precisely what this is the coordinate plane, right? It starts with the letter C, so that's a good way to remember it. Now, what is an angle in standard position? Well, over here I've got an angle. I can create an angle by rotating this blue arm in a counterclockwise direction, and I end up with an angle right here, which I'll call theta. This is what we would call a rotation angle, and this rotation angle is considered to be in standard position. Now, what makes it in standard position is the fact that the angle started along the positive x-axis, and I started to rotate through that angle and terminated at the blue arm, which is called the terminal arm. So we start with an initial arm, and we end at the terminal arm. Okay, and that's what makes it an angle in standard position. Now, it would not be an angle in standard position if, for example, this initial arm started somewhere else. If it started here and we created an angle going this way, or we started somewhere anywhere other than the positive x-axis. Right? If the angle started here, that would make it a smaller angle between the red and blue arms. That would not be an angle in standard position. Okay, so let's continue on. What are positive versus negative rotation angles? Well, I just drew a positive rotation angle, and a positive rotation angle occurs when you rotate in a counterclockwise direction. So let's say I rotate all the way to here, then that means my angle is going to be fairly large, right? More than 270 degrees. But that would still be considered a positive rotation angle. Okay. On the other hand, a negative rotation angle, which I'll draw in red here, would be rotating in the clockwise direction. So this would be a negative rotation angle. Coterminal angles, let me see if I can give you a demonstration of what coterminal angles would be. So let's say I have the angle 45 degrees. Okay, now the thing about the 45 degree angle is I could, let me just record that that's 45 degrees. I could also have another angle that ends in the same place, that terminates in the same place, if I wrap around the origin at least once and then an additional 45 degrees. So then that would end up giving me 360, right? That's the full rotation around the origin. 360 plus an additional 45 would be 405 degrees. Okay, now what 45 degrees and 405 degrees have in common is their terminal arm. They both terminate, both angles terminate in the same place. Right? Likewise, if I go with yet another color, starting from the initial arm along the positive x-axis, which is where all standard angles in standard position start, I can rotate counterclockwise and end up at the same terminal arm. And in that case, that would be negative 315 degrees. Now, all three of these angles terminate at the same terminal arm, which makes them coterminal angles. They share the same terminal arm. Okay, now, are there more? Of course. I could just keep rotating more times around or about the origin and continue to end at that terminal arm, and thus generate more and more coterminal angles. So coterminal angles are angles that share the same terminal arm. Now, principal angles builds off of coterminal angles. A principal angle would be, let's see, if I were to say that a principal angle is designated by the letter P. First of all, the principal angle has to be somewhere between 0 degrees and 360 degrees. Now, if you look at the previous example with the coterminal angles, we've got a 45, 405, negative 315 degrees, and more if you wanted to rotate about the origin, however many times you want. But out of those three that we've listed, 45 degrees is the one that is between 0 and 360 degrees. So in this case, 45 degrees would be our principal angle. The principal angle is really the smallest positive angle out of all of the coterminal angles. Okay, so really there isn't anything that I can demonstrate here except maybe show you another example. I can certainly do that. So if I take this terminal arm and I rotate it to, let's say, here. Let's maybe make it right there. And let's just say it's 100 degrees, right? So that's a little bit past 90 degrees, so we'll say it's 100 degrees. Actually, maybe I won't write it there. Maybe I'll write it over here. So we've got 100 degrees, and then we've got another coterminal angle that kind of wraps around and ends up here. So that would be 360 plus 100, so that'd be 460 degrees. We can also wrap around the other way. So that would be negative 260 degrees. And let's just do maybe one more. The last one, I'll put it in a different color. Maybe we're going around twice. And then again, well, this is getting really messy. Okay, so how many times did I go around? Once, twice, so 2 times is 720, plus another 100 is 820 degrees. Okay, so just to show that there are many coterminal angles. Now, out of all 4 of these, the one that is the smallest positive angle out of all the coterminal angles is 100 degrees. So in this case, P is equal to 100 degrees. And then finally, reference angles. Reference angles, quite easily put. Let me just construct an angle here. Let's just go here. Let's go back to the 100 degrees. The reference angle is defined as the acute angle between the terminal arm and the x-axis. So if you take a look, this is, let's say this is 100 degrees again. So if this is 100 degrees, this is an angle between the terminal arm and the x-axis, but unfortunately it's not acute. The acute angle between the terminal arm and the x-axis is in fact this angle here, which would be 80 degrees. So the reference angle is that angle between the terminal arm and the x-axis, and it's the one that is the acute angle. Okay, I'll show you one last example here of a reference angle. If I were to continue rotating this terminal arm to, let's say, here, and so what we have is, let's say that this is 260 degrees, right? So when we rotate up to here, it's 90, then 180, then 260 degrees. Then what we have here is really 10 degrees. Okay, but be careful, this is a common misconception. 10 degrees is not the reference angle. The reference angle is, in fact, the angle between the terminal arm and the x-axis, which is this piece right here. So since this is 0, this is 90, this is 180, and we end up here, well, this is beyond, this is 270. The angle here must be the difference between 260 and 180. So the reference angle here, I'll write it as theta r, is equal to 260 minus 180, which is 80. Okay, and so that is the video relating to angles in standard position and some of the different types of angles that we can generate from angles in standard position.